In this video, we are simplifying rational expressions. We are dividing rational expressions, and we are finding excluded values, what makes a denominator 0. So I have prepared for you 7 examples for us to go over together. So let me start with black marker here. All right, if you're looking at the first one, it's just the division of two numbers. I just want to remind you really quickly that we can really write 6 as 3 times 2. Therefore, I have some common factors. So my final answer is 1 over 2, and I can really get to my answer right away if I simplify top and bottom by 3. So there is my simplified answer. For number 2, if I start thinking about the same way, I have 8 and I have 3 x's. On the bottom, 24 can be 8 times 3, and then I have 1x. And if I start simplifying like terms, I have this is gone and this is gone. So I'm really left with x squared on the top over 3. Third example. All right, so let's see what's going on here. Well, on the top, I see that I'm sharing a GCF, a greatest common factor of 3. So I will start by simplifying the top by pulling out the 3. Therefore, I'm left with 3x plus 1. So remember, if you go and distribute, you should be getting what you started with. On the bottom, I see a GCF of 4, so we'll pull out a 4. And then I'm left with 3x plus 1. And now that I have top and bottom completely simplified, I'm just comparing, and I see that I have some like factors. So this is exactly the same as that, so it can go, and my final answer is 3/4. Now, the only thing so far from 1 through 3, the only thing where I had denominator to have a variable is number 2 example, and number 3 example. Number 1, I didn't have a denominator that had variables. So when you have a denominator with variables, you need to make sure you have taken care of excluded values. So if I go to the first problem here, number 2, the original problem, because x is on the bottom, I need to make sure, in order for me to do this problem, I need to make sure that x cannot be 0. Because if I put 0 in for x, I'm going to be dividing by 0, which is not allowed in math. Okay, so we have to exclude that. Same thing for number 3. If I want to find the excluded value for the denominator, I need to check what makes it 0. So I'm setting the denominator equal to 0, and I'm solving it. And I'm getting x equals -4/12, which simplifies to -1/3. So x cannot be -1/3 for number 3 problem for me to be able to simplify. Because if I put -1/3 to be equal to x here, I'm going to be getting 0 on the bottom. So excluded value means set your denominator equal to 0, assuming you have variable. Solve it, and that is the value that will make it 0. Therefore, you have to exclude that value when you're down from the problem. Let's go to number 4. For number 4, I have on the top, I see difference of squares. So let me go ahead and factor the difference of squares, x minus 3, x plus 3. On the bottom, between the two terms there, I see a GCF of 5, so we'll pull that out. So I have top and bottom completely simplified, and I'm checking for common factors, and I do have common factors. So my final answer would be x minus 3 over 5. And because my beginning problem, my starting problem, had denominator with 0, I need to talk about excluded values. So for number 4, I need to say that x cannot be, what would make the 0? -3. X cannot be -3. Everything else is allowed. So that is the excluded value of this problem. Problem 5 is very similar to 4 because I see on the top I have difference of squares. Square root of x squared is x. Remember, interchange the signs, and square root of 49 is 7. And if you do FOIL here, you're going to get what you started with. On the bottom, I see a GCF of 2. And I'm going to pull it out and write what I'm left with. After I'm done simplifying top and bottom, I see that I have some common factors. This and this can go. Therefore, my final answer is x plus 7 over 2. Simplified answer. Now, when I started the beginning problem, I did have a denominator with a variable. So I need to exclude what makes it 0. And this is maybe easier in the form that I have it factored. 2 can never be 0. What makes this parenthesis 0? 7. So x cannot be 7. For number 6, we have on top and bottom trinomials. So we're going to have to factor first to see what's going on, to see if we have any common factors. So I'm just reminding you of the process. This is telling you 2 of the same. This is telling they're both negatives. I need 2 numbers here. Their product would be 2, and their sum would be -3. Well, the only way to get a product of 2 is 2 and 1. They're both negative, so it doesn't matter where you put what. On the bottom, let me set up my parentheses. I need the signs to be opposite, one of each. And this is telling me that the biggest would be your positive. So it doesn't matter which one you put first. I need product to be -6 and sum to be 5. So it's what, 6 and -1. The biggest is the positive. So 6 goes here, -1 goes here. So now that you have the top and bottom completely simplified, you check to see if you have common factors, and you do. So the final answer would be x minus 2 over x plus 6. I need to worry about excluded values here. So x cannot be, this is the easiest, the factored form. What makes this parenthesis 0? -6. What makes this parenthesis 0? 1. X cannot be -6 or 1. Number 7 is very similar to 6, so let me get there. All right, on the top, let me set up my parentheses. Both the same, both positives. I need sum to be, a product to be 5 and a sum to be 6. So 5 times 1 is the only way to get a product of 5. On the bottom, I have opposite signs, one of each. Doesn't matter which one you put first. This is telling me that the biggest of the 2 numbers is your negative. How do I get a product of 2? Well, 2 times 1. And the biggest is your negative. So I want the -2 here and 1. All right, I have factored top and bottom, and I'm checking for common factors. And I do have common factors. This and this. So my final answer would be x plus 5 over x minus 2. I need to worry about excluded values here. X cannot be. What makes it 0? -1. What makes it 0? 2. So remember, we check what makes it 0, but we have to take that out because we don't want the denominator to be 0. That is it.